Question 5. A proton of mass m and kinetic energy k passes undeflected through a region with electric and magnetic field perpendicular to each other. The electric field has magnitude E. The magnitude of the magnetic field B is. So this problem, you can draw a proton which is moving with velocity v going this way. And let's say we enter a area that has electric field that's going up. So that's E field going up. And magnetic field is 90 degrees to it. So let's take it as magnetic field is going out of page everywhere in this region, going out of page and pointing toward me right now. So if you have a proton like this, and it's in here right now, for example, and it's going with a velocity v, so what would happen to the force? Let's take a look. Let's move this proton to outside here and draw that free body diagram. So this is the proton. The mass is m. So the mass is m, and the velocity is v. And we know this one has the electric force that's going up because of the E electric field. So this force due to electric field must be going up because the proton is positive charge. And for the magnetic force, since the magnetic field here is pointing out of the page, so if using right-hand rule, so the forefinger is the V direction, and then your bended forefinger, so 44 finger toward outer page, right? So toward outer page, then you can see the magnetic force will be going this direction. So that will be magnetic force will be going this direction due to the moving proton. So V going this way, which is the forefinger, and then this is outer page, which is the magnetic field. So then the magnetic force will be going to. So then this two will cancel because it's undeflected. So when they cancel, the Fe is equal to E electric field times the Q charge. So this is the M is the mass, but Q is the charge for the proton. And Fb, according to magnetism, this is equal to QVB. So QVB. So this two has to be equal. Fe and Fb has to be equal. So then you will have, so I'm going to write it up here. So EQ will be equal to QVB. So then Q cancel out. So then you can find B magnitude will be equal to E divided by V. So we know E. So E is inside the choices here. We got E. But we need to replace V by the kinetic energy K here. So we know kinetic energy K is equal to 1/2 mv squared. So then this one here will give us V is equal to 2K divided by m square root from here. So we're going from here to here. So once we have that, we're going to put this V back in there. So then this one here will be, so that's V is 2km. So the m will be going to the top and E going inside become E squared. And then this one here will be 2K. So that's the answer, me squared divided by 2K in the square root. So me squared divided by 2K. So the answer is D. That's the one. So that's the question. When a proton is moving with velocity v, and then it's undeflected in the region when you have both E and B field. So this is the B field right there. It's outer page. Okay, bye-bye.